Happy Friday, everybody. Welcome. My name is Sinai, and I help coordinate the Grad Talk series. And today we have a special guest joining us from Physical Sciences, Dr. Thomas J. Bussey. Thank you for joining us.
Yeah.
We will be taking questions in the chat. Feel free to put them in there if anything comes up. We are also recording the session, so if you need to leave early or miss any part of it, you can go back to it later on. We'll upload it to the website next week. All right. You have the floor, Dr. Bussey.
Excellent. Thank you so much for the invitation, and hello and welcome, everybody. I am Dr. Bussey. I'm an associate teaching professor and vice chair for undergraduate education in the Department of Chemistry and Biochemistry. And I was asked to come in today and talk to you about effective teaching strategies. But just to sort of preface the whole structure of what we're going to be doing, I wanted to shift the focus from teaching to learning, right? And the reason for this is that the idea of effective teaching, to me anyway, means that my students have walked away with an understanding that is deeper, more robust, and usable for them to go out into their other aspects of their life and do something with that information. So what I wanted to do today is focus on the learning process itself, and then talk about instructional strategies that are aligned to supporting the instructional process or the learning process specifically. So I wanted to start by just asking you to reflect on your own experience as a student in a classroom environment. You're probably all familiar with the very traditional model of instruction, of lecture-based or direct instruction. Quite often this is called the sage on the stage model of instruction, where the role of the instructor in this construct is to give information, and the role of the student is to receive that information. And that learning is structured around this very transactional model of the interaction between the instructor and the students. And that builds on this idea that students are essentially blank slates, that you're just sort of filling them up with information, and that information, your job as the instructor then is to just provide, right? The problem is that knowledge doesn't work like that. Knowledge is not an object. It's not a physical thing that you can transfer from one individual to another. Instead, what I want to do is consider some of the research that we have around learning and think about the implications of that research as it transitions back into the classroom. So if knowledge isn't an object and we can't just give students the things that we want them to learn, let's think a little bit about how the brain functions, period. So we're going to do a little bit of an experiment. If you have a pencil or paper around, you can grab that. If not, you can try and do this from memory. I'm going to show you a series of numbers, and I'm going to give you 5 seconds to try and memorize as many of those numbers in the order that I've given you, and try and remember as many of them as possible. All right? Everybody understand the rules of the road here? Great. So 5 seconds, go. All right. So now try and recall as many of those numbers as you can. If you have something to write this down with, go ahead and just jot down as many numbers as you can remember. If you don't, you can recite them back to yourself. The research around memory shows that people can remember about 7 pieces of information. So that means that students can do this first chunk of the information, or the first chunk of the sequence, pretty reliably and with high fidelity. And then we get progressively fewer and fewer individuals that can retain more and more pieces of information. So what do we do with this experimental data? Well, let's try and reframe what we're doing here. If we can only remember 7 pieces of information, think about what each piece of information is, right? If you attempted this task by looking at the number 3 and thinking of 3 as an identity of 3 objects, right? So 3 things, and then 7 is another piece of information, and then 3 is a third piece, et cetera, et cetera. Each one of these numbers can be considered one piece, right? But what if we change what the pieces are? So instead of 3 and 7, we could think about this as a new chunk of information 37, right? Or maybe even a larger chunk, 373, right? How you prepare the information, how you divide it up into manageable chunks allows students to actually progress further through this task. So if we try that same task again, we'll do a new set of numbers. I want you to try and chunk the information in a way that would allow you to identify more of these. I'm going to give you the same 5 seconds, and your job is still the same, trying to memorize as many numbers in the order that you've been given as possible. So let's try that again. All right. So this time, if you had successfully chunked information as either, let's say, 17 instead of 1 and 7, or maybe even 177 or 1,776, all of those could be considered one chunk. With those chunking strategies in mind, students can actually remember much more information, right? So this tells us a little bit about how the brain is processing this kind of information. Now, in a lot of our classes, maybe you aren't asking students to memorize strings of numbers, but the same idea still applies. They're trying to take in and integrate individual pieces of information. And if you can allow them or help them make connections between relevant chunks of information, they can actually retain more of that, right? The third experiment we're going to look at builds on some previous work in cognitive psychology. This one involves a video that I'm going to show in a second. And in the video, what you're going to see are 3 individuals that have white shirts on and 3 individuals that have black shirts on. And all I need you to do is just focus on the 3 that have a white shirt. They're going to pass a basketball back and forth between the 3 of those players. I want you to count the number of times the basketball gets passed. If you've seen this video before, don't ruin it for anybody. So just play along as we go. All right. And I'll turn the sound up once we get going here.
The monkey business illusion. Count how many times the players wearing white pass the ball. The correct answer is 16 passes. Did you spot the gorilla? For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it. But did you notice the curtain changing color or the player on the black team leaving the game? Let's rewind and watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold. When you're looking for a gorilla, you often miss other unexpected events.
So this is a particularly well-known experiment known as the selective attention experiment, where depending on what you're focusing on, you'll notice different parts of the representation that's being depicted for you. So what I want to consider is, what do those 3 individual experiments tell us about how the brain works, and what can we use from that in the classroom? To do that, I'm going to present 3 different learning theories and talk about some of the implications of these learning theories. And the first of those is cognitive information processing, or IP for short. And you can think of IP learning theory as basically that the student is a computer. And we'll talk about why that's a little problematic later on. But the basic idea is that there's some input or some stimulus from the outside environment. That sensory input needs to be sensed, right? So through visual information, through auditory information, et cetera. And in those sense memories, you have very split-second attention spans within these sense memories. not all of the information that you're being presented with is actually taken in. Right? So consider the gorilla experiment that we just saw. There's a lot of stuff happening, and depending on which pieces you are attending to, only some of that information is actually noticed. Once it's noticed, then it can be brought into what's referred to as short-term memory. This is a function of your brain where you have limited exposure, or limited access, I should say, to the information that's coming in. Usually around 20 to 30 seconds, that information is retained for. And then without rehearsal, so that's this top loop arrow, without rehearsal, that short-term memory is either forgotten or some of it might be stored in long-term memory. And it's this last transition that we're really trying to facilitate in a classroom context. We're trying to promote students' long-term memory storage of individual pieces of information that are relevant to a topic area, right? Even within long-term memory, though, some of that information is going to be forgotten if it's never utilized. So part of this process is not only introducing students to new pieces of information and sort of allowing them to bring it into their short-term memory, but also allowing students to retrieve relevant pieces of information from their long-term memory. And facilitating these storage processes is really part of what we're trying to do within the classroom context. A second way of conceptualizing the short-term versus long-term memory is to think about what are the different ways in which information can be perceived. And we're going to focus on particularly two channels in which visual and auditory information is going to be processed by the brain. So consider words versus pictures. Words are going to be sensed through the ears if it's auditory, if somebody's narrating or talking, or words can be presented as text. And if it's text-based, then it's going to be perceived through the eyes. Similar to that, visual representations are also going to be perceived through these visual channels. So the green line here represents the pictorial channel within the brain, and the blue line represents verbal channels. You'll notice that each one of these sense memory sections has a different connection to the working memory system. So what that really means for us is that information that's presented visually is processed in a different area of the brain than information that's presented in an auditory fashion. So that means that students have these two different channels that they can work through in order to get information into their working memory. If we present information that's only through one channel, then potentially students can miss out on some of that relevant information because they're trying to process too much through one of these mechanisms. We're going to look at a few strategies that play on this information processing model and try and promote information delivery through multiple channels. Once it gets into working memory, then we can integrate those sights and sounds and connect those two pieces of information to each other, and also organize a verbal and pictorial model by integrating both their prior knowledge about the topic with the new information that's being sensed. So with this information processing model in mind, we're going to think about a second learning theory. That second learning theory is going to remove the very logical computer-like student and center them more as an active participant in their own learning. The idea of constructivism as a model of learning is that we can't just think of students as this input-output model, right? It's not just that we're giving them information and then some of it goes in. It's that once that information goes in, the students need to do something to actually connect the dots, right? The student is the one that's actively constructing their own understanding. And this runs exactly counter to the transition model of teaching, whereas if I see my role as only giving information without creating a space for the students to do something meaningful with that information, then we're really circumventing students' ability to construct their own understanding. This allows students to integrate individual pieces of information that they're receiving with their prior understanding. And in this model of learning, their prior knowledge becomes extremely important, right? What students know coming into the classroom shapes how they view that experience. And I just want to highlight one particular example that's found in the research, and this is around students' understanding of mental models of the Earth. So even if you're not an earth scientist, you could maybe relate to these individual student conceptions. This is information that was taken from young students. So I believe they were in early middle school when this experiment was run. And the progression goes like this. if you talk to very, very young students, so elementary age students, they will tell you that the Earth is flat, right? And that understanding of the model of the Earth is drawn directly from experiential knowledge. They go outside, they look around, the Earth looks flat. You see this in young students' drawings of the Earth all the time. If they want to draw, outside, for example, they usually draw a linear line that represents the ground. Maybe there's a tree, maybe there's a sun, right? But it's this flat Earth model. And then you can give them some direct information about the Earth. You can tell students, well, no, the Earth isn't flat, it's round. And what they do with that information is they integrate their old understanding of a flat Earth with this new concept of it needing to be round. And then what we create is this new initial model of the Earth known as the disk model. And the disk model has a correct understanding of roundness, right? But here roundness is presented in this two-dimensional way. But the Earth is still flat to the student because that draws on, again, their direct experience. And then you can give them some more information. Tell them, no, it's not flat. It's a sphere, it's round, right? In 3 dimensions. And then for a while, students actually hold what's known as a dual Earth model. They actually have 2 different ways of thinking about the Earth. There's the Earth as if I was going to view the Earth from space, where it needs to be spherical, right? This might come from images like the one that's in the background of this slide. But it also draws on their direct experience that if I go outside, if I'm not in space and I see the Earth is still flat to me. And so individuals can hold these competing understandings of the same concept, even though they seem to be in direct opposition to each other. And then you tell them, no, it's not sometimes flat and sometimes round, it's always round. And they try and integrate those 2 ideas into this hollow sphere model of the Earth, where the student, instead of being on the Earth, is inside of the Earth, so that they can still reconcile a flat Earth perspective within the spherical model of the Earth. And then you can tell them, no, you're on the outside of the Earth. And then they think of a flattened sphere, so that the part that they can see at least is still going to be flat, but that it is now a spherical-ish model of the Earth that is consistent with what they're being told from an instructional standpoint. And then finally, hopefully we can get them to the full spherical model of the Earth, the accurate scientific understanding of the way that the Earth is positioned, by recognizing or allowing the students to recognize that they're just very, very small relative to the size of the Earth. What they see as flat is not actually flat, right? And developing an understanding of the curvature of the Earth takes some time and development. So the reason I'm going through and presenting this particular model of students' knowledge is to highlight the importance of their direct experience. Right? Students are coming in with all kinds of prior knowledge about the world around them. Some of it directly applies to what they're learning in the class, some of it doesn't, but all of it influences how they receive that information and what pieces they choose to, or maybe not consciously choose, but which pieces of information they pay attention to. The third learning theory that I want to introduce is sort of a next step of constructivism, in that constructivism focuses on individual knowledge construction, how the student individually constructs their own understanding of the world. This social constructivist model recognizes the fact that through language, the information that's being conveyed to students is being done within a social construct. Right? Learning can't be divorced from the social environment that the student is in. Whether that environment is the classroom, whether it's their home life, whether it's all the other experiences that are happening around them, that this way of understanding how students function is through an interaction between individuals, right? And it's that interaction that's creating the space for students to not only perceive new information, but how they're navigating and giving value to those pieces of information. So recognizing that the social construct of the classroom environment, the classroom culture that's being created, all of those factors are playing into how students are, again, selecting information and how they understand the meaning behind that information and what they ultimately do with it as they integrate it into their understanding. This can be seen specifically in the classroom, the physical structure of the classroom space, right? So think about, again, the traditional mode of instruction, where there's a sort of stage and an audience, right? This plays into the transactional model of teaching, where teaching is just the instructor going up to the front, conveying information as if they're in a stage production, and the audience sitting back passively receiving that information, right? This is not consistent with what we know about social constructivist learning theory, right? Instead, what you may have run into are new classroom design spaces that actually facilitate social interactions within this collaborative teaching and learning model. This recognizes the social interaction as being equally, if not more important sometimes than the actual direct instruction that's happening in the classroom space. And these kinds of collaborative learning environments are becoming much more common on campuses, although even if you look around some of the physical spaces on our campus, you'll see a mix of both traditional lecture spaces and more conducive collaborative learning spaces. But these kinds of spaces, again, are utilizing this social constructivist theory to integrate students to be able to network with each other, collaborate with each other and the instructor, so that the instructor is no longer the sage on the stage model. Instead, they refer to it in this mode of operation as sort of the guide on the side. So here the instructors may be wandering around, listening to what students are talking about, interjecting, asking questions, sort of guiding them in the right direction. And the argument quite often that I hear from colleagues is that this kind of teaching is a lot harder. It's a lot easier if I know what my script is, I go up, I stand, I deliver my speech, and then I leave, right? But I would argue that while this might be more difficult because there's a lot of unknowns in this environment, you might be asked questions that you weren't anticipating being asked and things of that nature, that the ultimate outcome for the students is really what's more important here. And that for students, this kind of social engagement within the learning process actually facilitates longer-term memory storage. So with those sort of propositions in place, I want to think about 15 specific instructional strategies or considerations for instructional strategies that are based on direct research. There's a lot of anecdotal information that gets thrown around when people talk about teaching and learning. And so what I want to try and focus on in this presentation are things that we have direct evidence for being successful or important considerations within the learning process. And as you'll see, many of these rely on some of our previous learning theory discussion to understand really what the implications of these strategies are. So the first strategy is to do nothing. The first strategy is to wait. Wait time is a really critical strategy that instructors should be using on a regular basis. And there's really two different kinds of wait time. What's referred to as wait time 1 is the time in between when you ask a question and then the first student responds. And it's suggested that you actually wait at least 3 seconds before interjecting. Now, 3 seconds doesn't seem like a long time, but for new instructors, this is a lifetime of dead air, right? There's a nervousness about not filling the space with sound. And so having this uncomfortable silence is uncomfortable for the instructor, but that's okay. It's uncomfortable for the students as well. What it's doing though, is it's creating space to allow the student to actually process what just happened. When you're asking a question, sometimes that question can be quite complicated for the student to unpack, right? And part of this process of being a student is that you don't know what these things are. And it's going to take some time to actually develop that understanding. So giving students just that space to process what you're asking them, that's really what wait time 1 is about. But even more important than wait time 1 is what's known as wait time 2. Wait time 2 is the time that you would wait between when the student responds to your question and then anything else that you would interject afterwards. By creating that extra space after the student response, that extra space quite often gets filled with other student voices. And the idea here is that what you're trying to encourage is you're trying to encourage students to explain what they think they know. And the more active participation in the discussion you can get, the more robust that conversation can be and the more meaningful it can be for students. So utilizing wait time has been shown to increase the quality of students' responses, because again, they have this time to process what's actually being asked of them. It also increases the quantity of student responses. More students are able to participate in the conversation by just not saying anything. So what I actually tell new teachers to do quite often is they will ask a question and then they have to count to themselves 1, 1,000, 2, 1,000, 3, 1,000 before they say anything else. Just giving that space can be really, really valuable. The second strategy I want to talk about builds on the social constructivist theory that we just looked at, and that's the use of small group interactions. Small group learning or collaborative learning techniques can range. I've listed a couple of them here. So predict, observe, explain is one common strategy that you might have seen. This is one in which you ask students to make a prediction about, let's say, an experimental demonstration that you might be doing for them. And then based on that prediction, students then get some direct observation. So you can show them some information, maybe a data set, maybe an experiment or something that they're seeing. And then with that direct observation, they have to create or generate an explanation. And through this discussion, you can allow students to not only recognize their own prior knowledge through this prediction process, but then how they reconcile their prior knowledge with their direct observation, right? The second strategy in this context is known as think, pair, share. And this is another common strategy that you see employed in classroom spaces quite frequently. The idea of think, pair, share is that students are first asked to think to themselves about a problem or a particular example or something of that nature. And then they turn to the person sitting closest to them. If this is in a virtual environment, this might be happening in a breakout room sort of scenario. And in that pair, they're asked to share each other's understanding. And by having to articulate what they think they know to somebody else, it actually forces them to think about what they think they know, right? This creates a more active engagement within the students. It gives them the space to first create their own understanding, but then also to try and understand what somebody else's perspective on this is. And then the share part of this process is to share out with the whole class what their final understanding is. And this is where the instructor then can serve as more of a guide in the conversation to direct or redirect student conversations in a productive manner. These kinds of small group interactions have been shown to increase student learning gains. They develop interpersonal skills, they improve students' self-esteem and retention within STEM programs in particular, and they increase enjoyment in the course. So these kinds of small group interactions can be extremely valuable. Again, this takes time away from direct instruction. My argument here is that the research shows that these kinds of time invested in small group interactions is actually much better for the student in the long run than the time that would be wasted or perceived as being wasted that could be directed towards direct instruction. The third thing to consider is what's known as spaced or distributed practice. And quite often practice is conceptualized within the construct of homework, right? This is the time where students go off and they work on things on their own. Well, humans learn best with repeated short periods of review or practice, right? And that practice needs to come with feedback. So for students to be able to effectively study, I'm sure we've all had this experience of needing to maybe cram for an exam. Distributed practice is the exact opposite of cramming. Instead of taking a short amount of time and trying to get a lot of information processed in that time, this is where students are going to take small amounts of information and spread it out, essentially, throughout an extended period of time to review. And the research in this area shows that even if you take all those short periods of time and that total time that they've spent, students are going to learn more from distributed short practice rather than the same amount of time as an extended cramming session, right? And part of this plays into what we talked about just in the limited processing capacity of the brain. There's only so much information that you can take in at one time. And trying to get more information in isn't effective. Your brain does not process that extra information. So it's more important that students actually take and structure their own studying process into these short chunks. And that those chunks need to include not only new information, but the review of old information as well, and the integration of that old information over time. The fourth is what's known as the coherence principle. And the coherence principle here is really based on this idea of cognitive load. So cognitive load theory suggests that there's three different kinds of cognitive load. There's the part that we normally think of, which is known as germane load. This is the information that's directly relevant to the content that they're learning, right? And that's actually the thing that you want them focusing on. That's the stuff that they need to take time to actually to process that information, integrate it with their prior knowledge. There's also what's known as intrinsic load. An intrinsic load is just the amount of processing capacity in the brain that is trying to reconcile the activity itself, right? If I'm going to do something on Zoom, or if I'm going to do a reading out of the textbook, those different modes of presenting information take different amounts of intrinsic load. So the idea here is that if we can reduce or simplify the complexity of how the information is being presented to students, or the more we can allow students to practice and become familiar with the way that information is being presented, the less time and energy needs to be spent by the brain trying to figure out just what's going on in the first place, so that again, they can focus on the germane load of actually trying to reconcile the information and solve a problem. The part of the coherence principle, though, is this third aspect of cognitive load, and that's extraneous load. Extraneous load is just distracting information. And the idea here is that we want to reduce, to the extent possible, any extraneous load. And you see extraneous load all over the place. It's that extra information that's provided within a reading, or maybe the extra picture that goes along with it that isn't directly related to what they're learning, or any additional information that's going to take time and attention away from the actual activity of interest. And so as much as possible, if that extraneous load can be reduced, the intrinsic load can be simplified, we can then maximize the amount of time and energy that the student can spend actually solving the problem that we're asking them. The fifth strategy that I want to consider is what's known as the signaling principle. And here the idea is that students don't know what they're supposed to see, right? That's sort of the joy of being a learner, is you don't know what you're supposed to learn, right? That's part of the process, is figuring that out. And so it's up to the instructor or the expert in the scenario to actually help direct and point students to where they need to pay attention. What are the things that are most important? How would I know that those are things that are important, right? How do I get them to focus in the areas that I need them to and not focus on the things that are not important, right? This becomes really important as they try and process large pieces of information that might be quite complex. There might be larger themes that are more important than some of the smaller details that are maybe easier to focus on or recognize initially. Often in this process, we ask new instructors to actually articulate their own thought processes to students. So I would, stand up in front of a classroom and say things like, well, when I look at this problem, I would start here because X, Y, or Z, right? Or when I do this, I would start and do this part first and then go to this one because, right? And just allowing the students to see your own thought process allows them to be directed towards the individual steps that are of most importance. The sixth principle that we're going to take a look at is what's known as the redundancy principle. And this goes back to the way in which information is processed through the senses. Both spoken and printed words are considered verbal information. However, the printed words need to be perceived visually. So what that means is that even though it's text, printed words are perceived in the same way that pictures are. Spoken words, on the other hand, are perceived through that auditory channel. Printed words and pictures, though, are both perceived through the visual channel. The research in this area shows that students learn best when there's narration and visuals, right? Because both channels can be activated, and efficiently you can get more information into working memory in that way. However, if you have narration, graphics, and text, the text competes with the graphics. And so therefore, if we can simplify and essentially reduce the amount of text that's being presented to students and supplement the text with narration, that's shown to improve student learning. This has implications in two important ways. The first, think about the current scenario of online learning. When we're presenting things like these PowerPoint slides or Zoom presentations, a lot of times you're going to see large blocks of text on the screen, along with maybe visual information and somebody talking. And that amount of information is just overwhelming. And the fact that the printed words and the pictures are redundant within this construct means that we can eliminate one of those two things. Because the printed words are being supplemented by a narration, it's preferred that the narration and the visual be the primary means that information is being presented by. That doesn't mean don't present text, right? It just means simplify where possible, right? The more visual you can make it and supplement the additional text with narration, the better. The seventh category we're going to look at is spatial contiguity. Here, what this means is that relevant information needs to be close to, in physical proximity to, the object that it's trying to represent. So here, text and visuals, when they're being presented, should be presented physically close to one another. Now, quite often, this information is presented in a legend, perhaps, or maybe in some sort of text that's presented separately. Think about the way that most textbooks are set up with this kind of information in it. It might look something similar to the image on the left. However, if we could easily move this legend information into the image itself, that actually reduces the amount of what's known as split attention, where the student has to go from, on the left-hand side, thing A, and then physically move down and figure out, well, thing A is this thing, and then go back up here and say, well, that thing was thing A. That amount of time to physically move back and forth within the representation takes extra time and processing capacity. If we can integrate that information into the visual, there's less time and energy that's needed to be spent by the learner going back and forth. And so we want to try and move relevant information as physically close to each other as possible. Similarly, we have a temporal contiguity issue as well. We want to make sure that the things that are being said and the things that are being shown are happening more or less simultaneously, rather than showing them something and then later talking about it, right? Even if it's presented consecutively, that lack of temporal integration means that students still have to try and remember what just happened and integrate that with what's being discussed at the moment. So we want to try and align two things, both physically and with respect to time. The ninth principle is segmentation. At this point in this talk, you've probably already checked out a little bit. Maybe you've looked at your phone a couple times. Maybe you're checking email right now. People are not designed to sit and listen to long, extended conversations. So all of these strategies that I'm giving you, I'm not using them right now, right? Or I'm using them to limited success, maybe. Segmentation means that learners are going to process smaller chunks of information more efficiently than long, continuous streams of information. Again, think about what this would look like in a classroom setting. Instead of sitting through an hour and 20 minutes of a lecture, where I am essentially doing nothing else but that's just listening and maybe watching something that's happening, if we can take that time and divide it up into small chunks where the students are going to shift their attention about every 20 minutes or so, that's segmenting the information, right? Or again, if you want to think about this in an e-learning context, instead of having an hour-long video lecture, breaking it up into, 3 20-minute chunks can be more effective in the long run, even though all the information is being presented essentially in the same kind of way. Again, the idea is that people have limited processing capacity. If you've ever watched a TED Talk, you may have noticed that TED Talks are limited in time. In fact, the rules from TED are that these TED Talks can't be more than 18 minutes. And why 18 minutes? Well, they did a lot of analysis on just how long people watched videos, and you'll see a large spike when people turn it on, and then that spike drops off pretty precipitously after about 15 to 20 minutes. So 18 minutes is their cutoff for this. And I would take that to heart, again, when you move into the classroom space. If you are taking up all the time and energy, the students aren't doing anything. And so providing opportunities to transition between what you're asking them to do, what they're doing, what you're telling them, what their activities are, all of those transitions help break up the experience for the student so that they're able to process the information and then practice using that information in different ways. So thinking about ways to segment the information in the classroom space can be really useful. Number 10, this is known as pre-training. Pre-training essentially sounds like teaching before teaching, which it sort of is, but we're going to sort of change that maybe a little bit differently and just talk about that in order for students to learn something efficiently and effectively, they need to have a coherent understanding of the basics that you are assuming. And most often people don't assume, or people, I guess, do assume that students understand things before you come into a classroom space. But very rarely do we actually ask students to demonstrate that understanding. In this context, I presented Bloom's taxonomy here on the right. in that this knowledge and comprehension section are their basic understanding and recall definitions, the sort of general terminology that they need to use. That's all information that can be tested for and sort of pre-trained prior to students coming in to do these higher level thinking processes, like analyzing some information or actually maybe developing their own problem to solve and something of that nature. In order to do those higher level processes, they need to have a coherent understanding of the basics. So not only testing diagnostically to see where your students are coming in at, but also potentially providing some relevant information or review of general information that you expect them to know coming in can be particularly helpful to make sure our students are starting at the level that you think is necessary. Number 11, we're almost through. Number 11 is about modalities. So I put this dual channel model up again to think about that learners are going to learn best again in the context that both visual and spoken words are being presented rather than visuals and printed words. And again, the reason for this reiteration here is that when you're considering developing and designing materials, having both visuals and printed words, while they can be useful in that context, it's actually more efficient and more effective that they have a visual and a spoken word implication. So here, the modality, the way in which you're choosing to present information can be particularly relevant in terms of allowing students to process more information more efficiently. Number 12. This is known as the multimedia principle. And the idea here is that learners learn best from more than just words and pictures, or learn better from words and pictures than just words alone. So quite often, especially at the collegiate level, we give students readings out of the textbook, and I don't want to suggest that those readings aren't useful. However, if we're only giving them access to information in that way, that's not particularly efficient. Bringing whatever is the relevant information back into the classroom space and allowing students to not only hear from you, but also see you using that information is much more efficient. Sometimes I hear from my colleagues that, well, I assign the reading, so I assume that they know. Well, if you didn't talk about it, what tells the student that they need to know that, right? So bringing these principles together and allowing students to process information through multiple media channels can be particularly relevant. Number 13, personalization. Here, this is more having to do with the conversational tone that you're using when you're discussing information. Quite often for new instructors, there's this maybe fear or perception that they need to be taken seriously. And so having an overly formal tone actually discourages student engagement. Having a more informal conversational voice as you're talking, as you're presenting information, as you're engaging students in conversation, tends to be much more effective to engage students in a longer term retention of that information. So thinking about the way in which you're talking about things, trying to eliminate jargon where possible to allow them to not only just process the information in a way that's less cognitively overwhelming for them, but also not as intimidating as they would otherwise have, that can be much more efficient. That doesn't mean that you don't want to teach them about the language or terminology that's used in the field. You absolutely do. But getting them to be able to understand how to use that kind of vocabulary is part of that process. The voice principle. So again, these last two are going to focus more on the e-learning environment, just given the nature of things at the moment, but this could be particularly relevant as we move away from emergency remote teaching. I would expect to see things like videos and online Zoom sorts of scenarios play out in the classroom space, even as we move back to in-person teaching. So the voice principle says that humans learn better from a human voice rather than a computer voice, right? And this isn't something that we deal with often, but it is something that you might want to consider as you're designing potential instructional materials, that it's more efficient and more effective to have your voice as the narrator than to let some sort of computer, Siri or Alexa or something like that actually do the speaking for you. And the last one is the image principle. The image principle says that humans aren't necessarily learning better from what are called talking head videos. And a talking head video is exactly what's happening right now. Like in the corner is my head that you're seeing and I am talking, and then you see the image that's on the screen. And this one, I should say, has relatively limited research at the moment because this is something obviously that's actively happening at the current time. But there isn't conclusive evidence that humans are learning more by being able to see that talking head. And the reason that I'm bringing this up at the moment is that there are two considerations here. If you're going to create video medium that students are looking at, do you want to be in the medium? Well, maybe. It depends what your instructional implication or what the instructional rationale is for doing that. Initially in the class, it might actually be really helpful to have your face as part of the information that they're receiving, so you can help to develop rapport and engagement with the students. They see you as a real person. However, over time, it may not be necessary that you appear in all the videos, that they might actually be better served by focusing just on the information that's being presented, and again, trying to limit the cognitive overload that's being presented within the particular medium that you're using. So just something to consider as you're moving forward, that there might be instructional rationale for why you would want to include a talking head and others where you may not. All right. A lot of these are based on huge amounts of research. And so I just wanted to highlight a few of the references that I'm drawing from. There are plenty of other references out there. So what I wanted to do today is mostly just highlight the fact that if you are thinking about engaging in some sort of instructional practice, there is probably a body of research about it. It doesn't hurt to go and see what somebody else has found, and utilize that research as you think about developing your own classroom implications or implementation of that material. And I just wanted to leave you then with a few takeaway messages, and then I'll open it up for questions. So the first take-home message is learning is not linear, right? Thinking back to the learning theories that we presented, learning is not this sequential process. Right? I hear again from my colleagues sometimes that, well, I said it in class, therefore the student should know. If you said it once, why would they take that to be more important than anything else, right? That the process of learning is actually an iterative process. So allowing students to practice and fail and use that failure as actually new information to productively fail in this process to move forward is really important. That they're going to need practice and replication of what they're doing over time, and a lot of feedback and help for you to navigate through this process. Just because they've seen it once doesn't mean that they've learned that material. The second take-home message is that learning is not fast, right? There's this understanding sometimes of good students that good students will just pick up the material and be able to do it quickly and easily. That's great if they have an appropriate foundation, enough prior knowledge, and they've been primed to be able to actually use that information. That doesn't mean that a second student who maybe doesn't have that same level of preparation can't ultimately do the same thing. It might just mean that that second student needs to take a different pathway to get there. And so thinking about this as not something that they should be able to just replicate information quickly and efficiently, that's not really effective learning. Effective learning is being able to get to the same bar at the end of the race. It might take them a different amount of time, but that's okay. And the last take-home message is this. Thinking back to both the constructive and social constructivist learning theories, knowledge has sort of these two components that I want to leave you with. Knowledge is individually constructed, meaning the student needs to actually do something in this process. The student can't just absorb information via osmosis. That's not efficient learning, and it's not effective. They need to have time and space to build their own understanding. However, in that process of individual construction, that construction is socially negotiated, meaning they're taking cues from their environment, they're picking up ideas from other students, they're hearing your perspective on things, and they're negotiating their understanding based on how the environment around them is valuing that information. And so thinking both about the student experience and the classroom culture that's created around that student are equally important. Thank you so much for your time and attention today. I know I've just rattled off a ton of information at you, but I am more than happy to take any questions that you have. I also put my email address up here. If you have any follow-up questions after today's presentation, feel free to reach out to me, and I'm happy to talk more with you about teaching and learning. And with that, I'm going to go ahead and stop sharing so I can see everybody. And if there are questions, I'm happy to answer those. I see Gary's hand.
Hi, Dr. Busey. Thank you so
Hi.
much for such a wonderful talk. So my question is geared toward students from diverse schools or institutions. So I'm just wondering how well has your model been tested in students from diverse institutions, and how well does it work? And have any differences been addressed?
Yeah, so that's a great question. The social constructivist theory in general, and a lot of other more advanced, and I should say, there's a lot of other learning theories besides the three that I've highlighted there. And those theories are increasingly recognizing the influence of factors of identity, the intersections of these identity factors, the culture that individual students are engaging in, and also the culture that's being created at the institution. And so the short answer is that I think while there is evidence that this is effective for students broadly from a lot of different backgrounds, that there is nuance that needs to be applied and understood for students from specific backgrounds, from specific instances. At the end of the day, what I would say, my takeaway is that all students are different. Each student is an individual. Everybody's coming into this experience with a different set of prior knowledges, with a different set of expectations about it, potentially even a different set of norms and customs. And with all of that baggage, maybe baggage is the wrong term, but with all of that prior information coming with them, that means that two students can walk into my classroom, experience the same, quote unquote, the same experience, but walk away with two different understandings. And so that's part of my understanding of this process as well, is that engaging in the learning process doesn't mean that everybody walks away with the same understanding. And at some level that is okay, right? But there needs to be benchmark measures that we can make sure that students are leaving well prepared to go on and do something efficiently or effectively. And those benchmark statements need to be assessed in a more robust way. I think there's a lot of literature that's conflicting in these areas at the moment. And so having more research around the effects of culture and the effects of identity factors are going to be much more valuable as we move forward in this process.
Great, thank you so much.
Yeah. Other questions? Allison?
Hi. I was wondering, and you kind of touched on it at the end of your answer there, if you could talk a little bit about how to assess, because everybody's knowledge is a little different, but there are benchmarks, like you said. So did you have any tips on strategies for assessment or evaluation?
Yeah. That's a fantastic question. I was actually thinking about this a ton last night because, if you noticed, I didn't include assessment in my discussion today. And to be honest, that's because I think there could be a whole other discussion, not just even a 50-minute presentation, but, many, many more conversations about what effective assessment looks like. And I think these two factors are actually quite interlinked. And so I think your question is really relevant here. How do you measure student learning if they're all sort of coming in at different places and leaving at different points, right? And so I have sort of two general thoughts on that. The first is, how do you know what somebody knows? And I say that sort of jokingly because the answer is actually we don't know what anybody else knows. And to be honest, I don't know that I know what I know, really, right? I don't know that anybody can really actually understand exactly what's happening at all times with all the pieces of information that are there, right? So I'm sure we've all had this experience where maybe you went in to take a test and then, you get to a question, you're like, I have no idea what this is asking. And then I, skip it and move on. And then I leave. And then, an hour later, I'm like, oh, it's that thing. And that information was there. It just wasn't accessible to me in that moment. So does that mean that I didn't really understand it? I would argue no, right? So again, sort of bringing this back to what do you do then? The first thing I would say is that you want to have multiple measures, right? So allowing students to demonstrate their understanding in more than one way can be extremely important to be able to make sure that you're actually capturing what students are doing. Because anytime they're, quote unquote, taking a test or a quiz or any of the traditional things that we would think of as assessments, that's a snapshot of that student. That doesn't actually tell you what the student knows. It tells you what they did in that moment. And so as an instructor, I take that with a grain of salt and say, okay, yes, this is what your performance was on this day. It doesn't necessarily tell me your understanding, it tells me your performance. And so maybe I have classroom policies that allow students to replace previous scores with further, scores later on in the course, because they're able to demonstrate mastery or demonstrate understanding. And for me, that's much more relevant as a marker for student understanding and engagement. And then the second aspect of that is making sure that the instruction that's happening actually aligns with the assessment. The alignment of the assessment and instruction is something that we don't, again, this could be a whole other talk, but you might be familiar with the backwards assessment model, or sometimes it's called BAM. And the idea of BAMing something is that the normal way that we would approach instruction traditionally is that you sort of go into your classroom space and say, okay, I'm going to teach about X, Y, and Z, and I'm going to do it in this way. And then I maybe design some lessons, and then they get implemented. And then I think, okay, now I need to write a test. And so I write a test, and maybe the test tests parts of what I did and maybe not other parts. And then we say, okay, we're done, right? And a BAM model would work and say, okay, do that whole thing, but do it backwards. First, figure out what you want the students to walk away with. What is the outcome you want? Then figure out, how are you going to measure that? What is your assessment of that outcome? And then design instructional experiences that allow students to develop the ability to do that thing, right? And some people argue, well, that's just like teaching to the test. Well, sure, but that's the whole point, is that you want students to be able to achieve certain things. So you're trying to eliminate all that minutia, all that extra stuff that doesn't need to be there, so they can just focus on the parts that you've deemed to be important. And so the assessment alignment is critical to that.
That's really helpful. Thanks. I would definitely come listen to a talk if you gave one on assessment in the future.
Awesome. Mohammed, I see your hand, and then I think we're almost out of time. But if there are any other questions after this, I'm happy to hang around for a few more minutes, and then you're welcome to email me as well. Go ahead, Mohammed.
Thank you. First of all, thank you for the talk. It was great. My question actually is related to a trade-off that I was often faced with between the amount of information that I want the students to be familiar with and the amount of understanding of the foundational information that I want them to be familiar with. So is there anything said about this trade-off and how to deal with it?
Honestly, I think what you've hit on is one of the issues that it's a perpetual struggle. And I don't know that there's a good way around it, because there's this pressure, I think, quite often to teach a lot, right? And then there's also a pressure of time and resources, right? And both of those things are limited. So at the end of the day, I would trade deep understanding of a few foundational ideas as more important than a surface level understanding of a lot, right? And what that means, honestly, is that I think at the end of the day, what we need to do is think about critically paring down the amount of information and think about creating experiences that allow students to efficiently and effectively and deeply understand the things that we've chosen to keep. Because then my argument would be, if I need students to learn that extra piece of information that I didn't teach them about, I need to give them enough information to be able to do that independently on their own. And that sort of lifelong learning part of this is, I think, more important. Developing students that are going to be capable of going out into the world, seeking out information, evaluating the meaning of that information, integrating it effectively. They're not always going to be in this formal environment. And so preparing them to be able to do that efficiently and effectively on their own, I think, is more valuable in the long run. But honestly, it's a trade-off. There's pressures on both sides of this argument.
Okay, great. Thanks a lot.
Yeah. All right. Again, if there are any other questions, you're more than welcome to email me. And thank you so much for your time and attention today. I've really enjoyed our conversation.
Thank you, everybody. Bye.
Thanks.